When you really think about someone saying, let's invent a telescope that can see back to the Big Bang, like, what?
The telescope will be so powerful. People will be simply blown away because they will not be able to recognize what they see.
Moving a $10 billion telescope, one wrong bump, and 25 years of work gone. Forever.
Working this job for about 24 years.
I started working on this project in 95.
2006.
20 years.
For 13 years.
They spent their careers working on this telescope, their entire career.
This is the James Webb Space Telescope. This bad boy, when fully deployed, with a primary mirror 6 times larger than Hubble's. It's the size of a tennis court, folds like origami, and took decades to build.
It will be about the size of a tennis court, the sun shield is, and it's about 4 stories tall. So in comparison to Hubble, for example, Hubble's about the size of a school bus. Webb is more the size of like a 737.
It's also the most advanced and most delicate machine humans have ever launched into space. And it took 25 years to build it, and it cost more than some small countries' entire economies.
The launch of the James Webb Space Telescope from French Guiana this morning. The $10 billion tennis court-sized observatory is the largest and most powerful telescope in history.
But before Webb could even touch a rocket, NASA had a new problem. How do you ship this fragile beast from California to a launch pad in French Guiana without destroying it? They couldn't just call a regular moving company and say, hey, we've got this $10 billion telescope. Can you guys handle that? No way. First, they had to build a custom container that could protect Webb from literally everything. Humidity, temperature changes, vibrations, dust, you name it. This thing was basically a high-tech fortress on wheels. Welcome to Space Aquarius. If you're fascinated by the incredible engineering feats behind space exploration, hit that subscribe button right now. NASA didn't just wrap the telescope in bubble wrap and hope for the best. They created something called STTARS, the Space Telescope Transporter for Air, Road, and Sea. This wasn't just any shipping container, it was a $1.8 million marvel of engineering designed specifically for Webb. STARS was essentially a mobile sterile room because the Webb telescope is so sensitive that even microscopic particles could damage its mirrors or instruments. Inside this container, NASA maintained fewer than 100 particles per cubic foot. That's thousands of times cleaner than a hospital operating room. The container had its own power system, climate control that kept temperature and humidity perfectly stable, and shock absorbers that would make luxury car engineers jealous. It even had its own air supply system that constantly pumped in ultra-filtered air to maintain positive pressure inside, keeping all those nasty dust particles out. Webb's primary mirror is made up of 18 hexagonal segments, each one polished so perfectly that if you scaled one up to the size of the United States, the biggest bump would only be about 2 inches high. These mirrors are made of beryllium, a rare metal that's lightweight but incredibly strong and coated with a microscopically thin layer of pure gold. The telescope's sun shield, essential for keeping the instruments at a frigid minus 233 degrees Celsius, minus 388 degrees Fahrenheit, is made of 5 layers of a material called Captain. Each layer is thinner than a human hair, yet tough enough to withstand the harsh environment of space. When deployed, this sun shield is about the size of a tennis court. Every single component had to be functioning perfectly for the telescope to work. There was no option to send a repair crew once it reached its destination 1,000,000 miles from Earth. This is why the transport had to be absolutely flawless. Getting Webb inside this container was like trying to fit an elephant into a suitcase, except this elephant cost $10 billion and could shatter if you looked at it wrong. Engineers spent nearly a full month carefully folding and securing Webb inside STARS. Remember, this telescope was designed to unfold in the zero gravity of space. On Earth, its own weight could damage it if not properly supported. Every component had to be carefully secured, with custom-built cradles and supports holding each delicate piece. The transportation plan wasn't created overnight. Teams spent more than 2 years mapping out every detail of the journey. They conducted multiple dry runs with a dummy payload of the exact same dimensions and weight as Webb. These practice runs helped identify potential issues before the real telescope was ever moved. The team even created detailed 3D simulations of the entire route, using data from laser scans of the roads and facilities. They simulated different weather conditions, traffic patterns, and even potential security threats. Nothing was left to chance. The first leg was just 41 kilometers from Northrop Grumman's facility in Redondo Beach to the port at Seal Beach. Sounds easy, right? Wrong. NASA literally used satellite imagery to inspect every inch of the route. They filled in potholes, removed speed bumps, and even lifted traffic lights to make sure Webb would fit underneath. The convoy could only travel at about 8 kilometers per hour, slower than you could jog alongside it. And get this, they couldn't even close the roads completely. Regular drivers were being escorted around this priceless convoy in the middle of the night. Can you imagine driving home late, being stopped by police, and then seeing this alien-looking container inching along the highway? Security was absolutely next level. NASA wasn't just worried about accidents. They had to protect Webb from potential threats, too. The exact details are classified, but we know there were armed guards, unmarked security vehicles, and constant communication with intelligence agencies throughout the journey. NASA even established safe havens along the route, secure locations where Webb could be temporarily stored if something went wrong or if a threat emerged. Talk about being prepared. After reaching the port, Webb faced its next challenge, a 16-day ocean voyage to French Guiana in South America. NASA worked with meteorologists and oceanographers to plot the calmest possible route across the Atlantic. The French cargo ship M.N. Colibri was specially selected for this mission. This wasn't just any cargo ship. It had specialized stabilizers to minimize rocking in rough seas and secure attachment points designed specifically for stars. Loading Webb onto the ship was its own engineering marvel. The container had to be kept almost perfectly level as it was driven onto a barge, rotated to face the ship's loading ramp, and then carefully winched aboard. Engineers used laser levels to monitor every millimeter of tilt throughout the process. During the ocean journey, the ship captain had strict instructions. Avoid waves over a certain height at all costs. The ship actually took longer routes to navigate around potential storm systems. Webb even had its own team of engineers on board, monitoring its condition 24/7. The ship's crew received special training on the importance of their cargo. One of the trickiest parts? Passing through the Panama Canal. The canal locks have specific size limitations, and STARS was designed to fit with just inches to spare on either side. As Webb passed through these narrow locks, teams of engineers walked alongside, making sure nothing touched the container's sides. The canal authorities provided their most experienced pilots for this passage. When Webb finally arrived at the port in French Guiana, the entire operation had to be repeated in reverse. Unloading from the ship, transferring to specialized transport vehicles, and driving to the Guiana Space Center in Kourou. The roads in French Guiana presented new challenges. Many were narrower than those in California, with more curves and different surface conditions. Once again, every inch of the route had been analyzed and prepared months in advance. The local government had been working with NASA and the European Space Agency for over a year to prepare the route. They reinforced bridges, widened certain turns, and even relocated some utility poles to accommodate Webb's massive transport container. It's worth noting that Webb wasn't just a NASA project. It was one of the largest international space collaborations ever. The European Space Agency, ESA, and the Canadian Space Agency, CSA, were major partners in the telescope's development. The Europeans provided the Ariane 5 rocket that would eventually launch Webb, while Canada contributed key scientific instruments. This international collaboration extended to the transportation effort as well, with multiple countries coordinating security, logistics, and engineering expertise. When Webb arrived in French Guiana, it was greeted by a truly international team of scientists and engineers, all holding their breath that their precious cargo had survived the journey unscathed. At the launch facility, Webb was finally removed from SATARS in another ultra-clean environment. Teams of engineers spent weeks performing final checks, making sure nothing had been damaged during the journey. The telescope was then carefully folded into its launch configuration and placed inside the nose cone of the Ariane 5 rocket that would carry it to space. Even this process took weeks to complete, with hundreds of checkpoints along the way. And on Christmas Day, 2021, after this incredible journey across continents and oceans, Webb finally left Earth behind, beginning its million-mile journey to its final destination at Lagrange Point 2. For decades, we've relied on the Hubble telescope to show us the cosmos. And Hubble is amazing. It's like having incredible binoculars. But Webb is like giving astronomers superhero vision. Webb sees in infrared light, which is invisible to our eyes, but perfect for spotting things that are super far away or hidden behind cosmic dust clouds. It's like Webb has X-ray vision for the universe. Regular telescopes hit a wall when they try to look through massive dust clouds in space, but Webb cuts right through them like they're not even there. This means we can finally see what's happening inside the cosmic nurseries, where stars and planets are being born. When NASA revealed Webb's first images in July 2022, it broke the internet, and for good reason. These weren't just prettier space pictures, they were revolutionary new views that changed how we understand the cosmos. Right now, Webb is orbiting the Sun about 1 million miles from Earth. It's in a special spot called Lagrange Point 2, where it can keep its tennis court-sized sunshield between itself and the Sun at all times. This keeps its instruments at a frigid -388 degrees Fahrenheit, -233 degrees Celsius, cold enough to detect the faintest heat signals from the most distant objects in the universe. Webb is collecting about 57 gigabytes of data every single day. That's enough to fill your smartphone. Scientists back on Earth are pouring through this cosmic treasure trove, making new discoveries almost daily. The telescope should work for at least 10 years, but engineers are hoping for 20 or more. And the most exciting part? The biggest discoveries probably haven't happened yet. What space mystery are you most excited for Webb to solve? Drop your thoughts in the comments below. And if you're fascinated by the incredible stories behind humanity's greatest achievements in space, press that subscribe button to join us for more cosmic adventures here on Space Aquarius.